Hello and welcome to the Kim Corner, episode 4. In this episode, we'll be trying to get Microsoft Basic running. It's been released on the public domain now, so we can run it without any royalty issues. We're going to get it running on, this is the memory board, which I've populated with 4 ROMs and 3 more RAM chips on there. So we've got a full 60k sitting on here. Well, actually, no, 56k. The Microsoft Basic, you can get a version that will run from address 2000 in hex in RAM, but I'd like to have had it in ROM, so it's there straight away and you don't have to keep loading it back in. And it gives you more RAM down here, I suppose, for programs, or you could put RAM up here as well. As I mentioned before, these are meant to be RAM sockets, but you can put ROM in them as well. You can swap and change whichever you like. I decided to try and get the Microsoft Basic running in ROM starting at address A000 there. It has to go across 2 ROMs because it's about 9k in size and these are only 8k, so it uses part of this one as well. I think I might actually move it up to here so I can save that space and put more RAM through here. This ROM at the moment has just got a bit of test code in, which I'll show you shortly. I wrote that to try and find out if I still had some problems with the actual KIM board. Here we have on GitHub the repository of the actual Microsoft Basic. I'll leave a link below so you can find it yourself. This is the original one. I did lean quite heavily on the works of Ben Eater for compiling Microsoft Basic for another computer. I decided to go for this source here rather than his because he's fiddled around with some of the settings on his one, and I don't think it was causing me the issues, but I wasn't sure. So I thought I'd try from fresh to make sure, because we need to modify some of these source files and configs and defines, etc. When the basic is compiled, it creates a lot of vectors on the 0 page. And some of the times the program would run partially, basic would run partially, but not fully boot up. And I was wondering whether it was going to the wrong vectors or something, wondering if I'd still had an issue with the 0 page. Because I'd changed 2 of the chips on there, as you may recall. So that's these ICs up here. I'll replace these bottom 2. But could there be an issue on one of these memory chips that I hadn't fixed? So I thought I'd write a bit of code to check all them out. And I'll burn that into a ROM to test them. So here's the code we're going to put in for testing the 0 page RAM. We're going to put this through an online assembler to get the actual binary. But we'll start with here, we've got some vectors within the KIM-1 ROM. There's this one that's CRLF, that sends a character return line feed. So if we call this address here, it will send those bytes out of the teletype port. And we've got out character, so we call that address and it will send a character out. You put a value you want to send, say 65 into the A register, and then call this and it will print a letter A. And then there's out SP, that just sends a space. So you could use this one with a value in there in the A register, or you could just use this one for sending a space. Then there's print byte. This one's quite handy. You send it a byte in the A register, and it will split it into 2 halves, and then print the hexadecimal value of it. So if you sent it this 1E, that'd be a whole byte. If you sent it, put that into the A register, this will then send a 1, an ASCII for 1 and an ASCII for E to the teletype. And this save 2000, that's just a memory location, because when you call these vectors, the A and X registers get destroyed. So I'm going to have to save where my counter is for doing the memory testing, what the address is. So I'll just use this memory location here. And it's all 8000, that's just going to tell the assembler that this code is meant to be starting at 8000, so adjust all the labels to match. And the actual code is starting here at 8022. So we load X with 0 and store that in that memory location called save. We then load A with 0 and we print that out as 2 bytes. We get 00 coming out on the the teletype. And then we load A with what's in the saved port, so that'd be what X is going to be. Put that back into A, and we print that out as well. So it will go 0000 at this point. Then it'll send a space. Then we load A with 55. So that's bit pattern 01010101. So it's every other bit is turned on. And then we print that on the screen again. So that's what we're going to be sending. And put another space. Then we have to load it again here because it's going to get destroyed in there. And we load X with the value that was saved here, which in this case will be 0. And then we're going to store this 55 here. We're going to store that in memory location 000 plus X, which in this case is 0. So we put in the value of the 55 here into memory address 0. We're then going to read it back to see that it'd been saved correctly. And now at this point, because it's in register A, we can then print it as 2 ASCII characters, then another space. And then we can do the same again here, looping around again, but this time we're going to use AA, which is 10101010. So it's the opposite bits to 55. So we print that out, load it into A, send it to the memory address, and then read it back and print it again. Now here we load X with what we saved in memory, we increment it, so it's now got a 1 in there, and we save it back. Then if it's not 0, then branch back up to here and start the same again. But this time as we come through, when we come to this point here, X has got a 1 in it, so we're doing 000 plus 1, so that's address 1. So we're doing the next memory address, and we go around that again and again. And that will keep going until we loop over and X gets turned from 255 back into a 0, and then it is a 0, so it will carry on. And we do the same thing again here, but this time we're loading A with a 1 and printing it at that point, and then 55 again. So when we come to this point, this is the bit that does the business. We're doing 100. This one here is just so it prints 0, 1, and then whatever's in the X register onto the screen. Here it actually goes to address 100 plus what's in X. So the other one done 0 to FF. This is going to do 1 to 1FF. And then same again down here. This time we're going 2 to 2FF. And then 3 to 3FF. Doing this bit pattern F55 and AA all the way through. And if any of them come back with the wrong value, then we know the memory is not working properly. And when that's finished, it just sits in a loop at the end. So we can see all this come out on the screen to see whether the first 1K of memory is working okay or not. So to compile that, so I'll just have to do Control A to select it all, Control C to cut it, and then Control V and put it in here. And now we can assemble it. And there it all is assembled, all the code's assembled. And here it all is in a binary. So we can then just download the binary, generates it, we click there to download it. And that's ready to burn into the ROM, starting at address 8000. It's only a short little program. There we go. I'll burn that into the ROM and plugged it in this ROM here. That's starting at address 8000. Oh, can you see that? Address 8000. So we plug this in now and run it. We'll see what we get coming up. Okay, let's plug that in and then run up the terminal. So if we load up PuTTY, here we go, we've got one set up already. KIM-1, load. That's set for 1200 baud on COM3. And we open that and we get this screen. Backspace, there you go, we're talking to it. So we need address 8123, space to go there. And then just capital G and it goes. And there's all the addresses of the memory we're testing and the values we're putting out. So the first 55 is what we sent and the second 55 is what we read back, and same with the A's. And that will just go through all the memory in the bottom 1K, testing the onboard RAM. And there we have every byte of RAM checked through, and they all seem to be working okay. So we didn't have an issue with any vectors being put into the 0 page. So if the problem didn't lay here, maybe it was in the compilation that I was doing, because I was trying to move the MSbasic to run from ROM higher up, but I also needed to point it at the RAM, where the RAM is, because it keeps trying to look at address 200. And I'm not filling the RAM in from there, I'm filling it in from 2000. So I need to change the pointers of that as well. Well, whilst searching around on the internet, I come across this site. This is w9oms.com. Some guy who plays around with KIMs as well, and he's got copies of Basic and that there. And if you scroll down, he's got it in this, what's called PTP. This is the paper tape format. We've downloaded the actual file there. And this one is designed to run from address 2000. So it's in RAM. You know, it just says here, cold start from here. That's the actual entry part to the ROM code. The whole program starts at address 2000, but to enter it, to start it up, to run it, you have to go to this address. That's then in the RAM at the bottom. So what I did is I got a copy of this and I loaded it in. I'll show you how I loaded it in. This is quite useful, this feature. So here we have TerraTerm running. Press delete to get it to talk to it. For some reason it puts these characters at the front. Not sure why. Might be the KIM sending null characters or something. Right, now to load, press L. And now we're going to send the file. Okay. There we go, at 1200 baud. And that will take about 3 or 4 minutes to load in. Here we are, nearly finished. 99%. Last few bits going in. And it should return back to the KIM terminal. Now to run this, we should be able to go 4065 space to actually point the monitor at that address. A2 I recognise. Now let's see if this works. Press G for go. Yeah, it's working this time. Alright, memory size. You don't have to type anything in. If you don't type anything in, the basic program will actually measure your memory from, in this instance, the top of the unused RAM above the program to the top of memory. Or if when we got it in ROM, it will do it from the address that we tell it. Memory size, and it asks for a terminal width. That's by default is 72. That's mostly for if you've got a printer. We just press enter there. Now, do we want the sine, cosine, tan and arctan functions? Well, we're going to say yes at this point. Carry on. The idea of that is it can, if you don't want those, then it will overwrite them in RAM and save that RAM for your basic programs. Now, this is saying we've got just over 16K of memory free. Then print there you go. No, I think I've got that right. 20, go to 10. We can list that. There we go. And we can run it. And there we go. So Basic's pretty much running. Control C should break that. But I might have to press it a few times. Oh. And what's going on? Come on. There. Ugh. There we go. Managed to break in. Because of the way the KIM reads the keyboard by using software, it's a bit difficult to break in. But if we do a list, it's still there. So we know it runs, and it runs in RAM. We want to get this to run in ROM. So we've got a version here. If you look in the background, you'll see I've got this file here, which is this turned into binary. So I could compare it with my version that I compile. So it was crashing right at the beginning. It will be doing that part where it says loading the memory, etc. What memory size do you want? And then as soon as you've done that arctan bit, it will crash. And that is within the first 200 bytes, if that, of program. So I'll be able to compare with this one we know that works. And we'll see where we go from there. Okay, so we go back to this board here. We know BASIC works when it's loaded in here, in these chips. But when it was loaded in here, it didn't. So I took these, which one was it? This one. Because this is the one with the initialization code in, because I couldn't see hardly any difference between the RAM version of the BASIC that was running and what I had compiled. And it was crashing well before we got deep into the program. And the code was almost identical, so I just couldn't see what was happening. So I thought, I wonder if it's anything to do with this socket. So I put a spare RAM chip in that socket and tested it. I could do that with just a monitor, just by writing numbers in and reading them out again. And I was getting all sorts of gobbledygook. So it was a socket that was causing the grief. Now what we're going to do is we're going to rebuild the BASIC. At the moment it's sitting in these two ROMs and it works. But this one is virtually empty, only 6 bytes that this is used for the reset vector. So I'm going to put basically that ROM there and that one in there. But I'm not going to move the ROMs, I've got to recompile because I've got to tell it to come start at a different address. If I take these out and get this out, it's a right job to get out. You may recall I mentioned about using this sort of socket so it's easier to push the chips in and out. That came out amazingly easy. But this socket here had a failure on it. And you see that pin there's bent up a bit. And we're going to take that one out as well. Oh, I just squashed that one. Now, this one shows it a lot better. You see how all these pins are bending up. It's pulling them out and they're getting damaged. So I've concluded that £8 for 50 sockets is too cheap. These are just Chinese crap. And they caused me no end of grief. Just now when we was loading BASIC up into RAM, I recorded that 5 times. And what I've done to get it to work is I pulled this chip out a bit and put it back in again. It's got one of these sockets in it. So what I'm going to do is this one's got a round pin. I'm going to change them all for round pin and swap these square ones. This, well, the square ones might be okay. You know, all these flat, double edge ones, okay, but not these particular ones. This batch is just rubbish. So we get decent quality ones, branded ones. Alright, one quick solder later. Took all those flat pin or double white sockets out and put turn pinned ones in. Okay, after a bit of fiddling, them in there. Okay, to compile the ROM, we have a program here called CC65 living here, and it's going to do the compiling for us and assembling and linking. There is a from the repository in GitHub here a make file in here, be under M then, won't it? There we go. Make sh. We open that, and basically it makes all the different versions of the software and compiles them all. I couldn't get this to run directly on my install, so I just copied these lines at the bottom here that tell it to build it, and I only want to build the one in here. I'll come up with a text file. Whoops, not that one. That one. How to get things to work. There we go. You spread that out a bit because it's long lines. So I installed my, well, copied and unzipped the C65 just onto this directory. To compile the code, I just have to run these commands down here. If you actually look into the code what's there, we've got some things I had to modify. So it's these ones at the top. So there's defines KIM. On here, I got this, there's this line here that says config RAM. Let me bring that into the middle of the screen. It says config RAM equals 1. That means make a version for RAM. When I want it to run it in ROM. So you have to just comment that out because it doesn't care what value you've got there, just that that config RAM is defined. So if I undefine it, it doesn't do the RAM part of it. And what it does do when you compile it without the RAM, it wants a space for this user. There's a user 1, user 2, user 3, and there's one for user as well used in the code, but only for the ROM version. I'm not sure what it does, but I had to find somewhere for that in the 0 page. And there's others in the 0 page, but if I popped it next to those, it would upset this list in here. And some of the 0 page variables will then have, like Z17 is at address 17, but it would actually be at 20, so it makes it a bit confusing to read. In the documentation, it says it only uses the 0 page up to DD. I didn't stick it right there, so I thought, well, there's nothing being used at FO. No, there is at FF. So I just stuck it up there. Bit of a guess, but seems to work. Didn't touch any of this. And these got these magic memory locations. There's something to do with the punch tape or whatever. I don't know what they do. I haven't looked at them yet. And then you've got this mon-R key and mon-C out. That's read key and character out. These are the addresses that are in the KIM-1 ROM that actually send a character out or read one back in. We used them in that previous little test program to send characters in and out, or if it wasn't these exact ones, similar ones. And then I did this line, RAM start 2 equals 2000, to tell it that's where the RAM starts. And there was something really weird in the KIM thing, because what it does, it loads in this one as well. Oops, bring that other one back up next to each other. And this one, it had RAM start 2 there, and then this code here, and it's a segment. So it's actually putting these bytes into the memory segment that gets loaded in right at the end. I haven't a clue what these do. They don't appear to be machine code or ASCII or whatever. Because I was having so much trouble getting this to compile. Well, to be honest, I wasn't having trouble getting it to compile. It was that socket that was causing all the grief. So I put them in. I just called it odd stuff. So it gets put at the end, and they appear on the end of the binary as they would before, and I don't know why. You have to take the RAM2 start out of here, because that's a segment, not a declaration. So I'll need to put it there to tell it that's where memory starts, which works. Well, what else do you have to change? And there's this KB9 config. This is where it gets a little bit confusing on here, because everything else is called KIM, apart from this bit, which is KIM-basic 9 config. And that's where you've got stuff here. So 0 page is down the bottom there. Base of the ROM, right, we're going to have to change this one. I've got it as AO. We want to move that up to C00. So we take that and put a C there. The ROM size is a bit small for some reason, but you've got this dummy thing, and they all seem to go to 3F rather than 4000 there. And I don't know why, but leave it alone and it works. So let's save that. So now when we compile it, it should compile to that address. And there's one other thing I changed as well, is in the actual compiler. If you look in here, this is all the include files. There's a KIM-1 include file. Then here, it's got RAM start, and that was at 200. I'll change that to 2000 as well. I don't know how important that is. Here again, you've got all the different start points for different things in the KIM-1. Call it a BIOS ROM, I suppose, or the monitor ROM at the bottom. But I just changed that one now to 2000 because I was having trouble with it, and I don't know whether that's important, but it works with that set. So now we need to compile this. So if we pop back to this bit here, we go to these addresses. Now this is all command line stuff. So if we go to command line, we come up in drive C, we need to change that. So we go to, in my case, it's drive E, and then we're going to have to change directory, and we'll change directory to where the compiler lives. Control C, how I see, I've done change directory twice. There we go, we're in the binary. And now if we cut this line here, this is saying, I'm not quite sure what these bits at the beginning are for, but we're doing KB9. This is where the source is, and we're going to put the object out of this file in a directory called temp. Enter, there we go, that's just done that. And then the next one is going to take that object file and the configs, and it's going to build the binary and a label file. A label file allows you to see where the start of the program, etc. is, if you've got problems. Right in there. There we go. Now that should have compiled everything. If we look back to where it should be, C65, we've got, if we look in the binary, there's a temp directory in here. And there, we looked in here before, but this has been updated. This is now. Yeah, that's the new version. Got this label file in there. That tells you where all the different bits are. And there's one called cold start. So search on cold. There we go. Cold start. E065. That's the starting address when we load the ROM in and bring it over here. That's just there. That bit there. So E065 is our start address. I've found all this out by watching the Ben Eater video about running Microsoft Basic on his computer. There's the binary. We need to burn that into EEPROM now. And we need to go and find the EEPROM burner. Here's the EEPROM programmer. So let's get an erased EEPROM, pop it into the programmer. We just read that to check it's correct. Read. I've already set it up for the right type. And it's all Fs, so it's blank. So now we'll load in KB9 that we just created. Okay, there it all is. So I'm going to program it. I'm going to program it again. Well, I've found that doing them 2 or 3 times sort of puts the program in good. Sometimes when you do it just the once, it doesn't go in properly for some reason. It says it does, but I've known them to fail. It doesn't hurt to do it again. There we go. And what we can do is we can do a read. Yep, it's all in there. Right down to the bottom. Yep, okay. So that's that one done. That's the bottom of the 2 EEPROMs. That goes in C0. Now the next one, now we read that, just make sure it's empty. And yep, that all seems clear. Now we've got to load the same one in, but this time we're telling it to load from 2000 onwards. First time I've done this, I split the file, but you don't have to. You can actually do it in here, in the programmer, to tell it, take it from 2000 onwards. So okay, and there we go. It's put it in at the top there because there's nothing at the bottom. Now, before we program this, because this ROM's going to go to the top, it's got to have the reset vectors put up here. So we want the top 6. So that one there will be 1B. The next one will be 1C, 22, 1C, 1F, 1C. There the reset vectors put back in. Double check that. Yep, so it will read this one here, 1C22, which is the start of the KIM-1 ROM. What we do now is just program that. A little quicker because it doesn't have to do so much. I go back. Now let's read that back. And all in there. And we've got the reset vectors at the top of ROM. So what we've got to do now is plug these into the board, plug it in, and see if it will work. So here we've got to plug it in the board. So that's CO. Right, those sockets are certainly harder to press into. Now we've got to plug that in and see if it works. So here we go, back at the KIM again, and we just plug this in. Okay, it's all in. Supply's all correct. Yeah, turn it on. And press reset. There we go. Alright, KIM-1, load, open. On a different screen. And backspace. Here we go, talking to it. E065 space. We're there. Go. Hey! Memory. Terminal width. And there we go. So that's like 24,575 bytes. We've got 3 RAM chips plugged in there. That's 24K. There's a few bytes being used by the looks of it. But right, let's start again. So 10 print oh, we go to 10 lists. There we go. Control C several times. Come on, out we break. There we go. Managed to break it out. Okay, so we've got BASIC running on there in the top ROMs. So that's good. We can use that for the next adventure. So here we are back on the other camera, and we'll be doing this in the next episode. And we can use this BASIC program running to help test this, because I don't even know if this design will work. This is a Intel chip, it's a 6251 UART, and not designed to run with a 6502. So I'm not sure what's going to happen there. The reason I use this chip is because I got 4 of them, rather than buy another one. So quite a simple board there. We'll go through this in the next video and see if we can get this working. So don't forget to like and subscribe, and I hope to see you in the next episode where we'll sort this one out.